Hi, it's Steve with Paladino Power Project, and I'm going to bring you a video about some of the options that you have for calculators um, for CP. Um, these are when I speak of calculators, I'm talking about calculators that use models other than multi-parameter power duration models like Stride's Auto CP model or WKO or Golden Cheetah. Those use a larger database. Here on these calculators, you're sort of cherry picking your full effort tests and races to enter to arrive at CP and a W prime, or what we call reserve work capacity, RWC. So this one here is one that I've been using for on occasion for the last couple of months, and it's from ExPhysLab. The people behind it are awesome. Felipe Maturana has had some great articles stuff, and Juan Murias. They're behind it, and it's a really good product, and that's why I'm bringing it to you on video. They do appreciate Patreon support. I use Patreon. I have supported them with Patreon. If you use this a lot, consider supporting them with in Patreon. They just look up ExPhysLab on Patreon. So let's get into it and look at the actual calculator. Um, so this one here allows you to evaluate critical power, but if you don't have a power meter, you can use critical speed. Critical speed just asks you to enter the distance and the time for the tests, and we'll get you your critical speed calculation. I'm going to limit my discussion to critical power. This also allows you to add multiple tests or races. Um, the problem here, and my advice to you is, you don't want to use test or race data that's widely separated by time. Like, something 3 months ago, you're in a different shape 3 months ago than you are today. So if you do a CP test today, and maybe you did a 5K 3 or 4 weeks ago, that might give you a pretty good um, uh, validity on your CP estimate and your RWC estimate. But when you start spreading those the dates of those particular tests or races to a longer duration, then it's not as valid for where your CP is at currently. So um, select the number of data points that you have to enter. Um, just an important note, make sure you do this before you start entering data, because once you start changing this, then it'll take out data points that you've entered. So I'm going to use an example of some recent data from a runner, um, and the powers were 363 watts for 3 minutes and 8 seconds. This one, unfortunately, is you have to enter. Well, let me see. Yeah, it doesn't allow you to enter minutes and seconds, so you have to convert everything to time before you get to this. So the next one was 329 watts for 12 minutes and 6 seconds, which I've already done the maths on. And the last, those are two from a CP test just recently, just recently. Um, but then about 6.5 weeks ago, the athlete did a 5K race, which I'm going to enter. Remember, 6.5 weeks is really stretching. I probably would avoid that in many cases, particularly if either environmental conditions have been changing rapidly or someone's physical fitness has been changing rapidly, either up or down. Then you don't want to include those older data points. Ideally, you'd like to have something within 2 weeks to 3 weeks and even up to 4 weeks. Once you get beyond that, then you have fitness changes and environmental conditions changes that may be factoring in and giving you uh, some variance away from validity. So this one here was 1273 seconds. And so what it has is it allows you to do a simple analysis, which simple analysis meaning that it's taking all three of those values, all three of those tests. One other thing I want to insert here is that this was a CP test. It was the air power was good on this CP test. This one was a 5K, 6.5 weeks prior to this. That's a little bit of a red flag. Plus, it was in one direction on a coast and may have had a little tailwind, which means the air power was on the low side. So there's a couple little red flags, but I'm using it for example here, for an example. So I have 3 data points. So a simple data analysis uses all 3 of those and only 3. All possible combinations means it'll do 1, 2, and 3. It'll do 1 and 2, 1 and 3, 2 and 3. It'll do all the different combinations or permutations of whatever you're inserting here. And I'm inserting 3 values. Let's take a look at that. So I'm taking that one and I'm going to press go. And there is the results. There are the results. And so the great thing about this calculator is it gives you different models. Now, that said, the linear 1 over time, a CP model, this one right here is probably the has the best validity for runners, and this is about runners. So if I enter this data, the CP value with the CP1 over time is 311, and the standard estimate of the air for CP you can see is the lowest of the 3 different models using all 3 data points, 1, 2, and 3. And the W prime is lower than the other 2, and the standard error of the estimate there is also the lowest. All right. So this is the model I suggest that you use if you're using multiple data points. So as you start looking at combinations of 2 data points, 1 and 2, the hypotenuse version here is drops out because it needs at least 3 data points. The linear and the linear 1 over time models produce the same outcomes, the same results. So when you have 2 values, these are essentially producing the same results. Whether it's point number 1 and 2, that's the 3-minute, 12-minute. 1 and 3 is the 3-minute and 21-minute, and 2 and 3 is the 12-minute and 21 minutes. So I would never use this because it doesn't have a short enough value or data point. These 2, you can take another look and you can see that the CP test, the 3-minute from the CP test, and then the 5K gives you 306.7, and the CP test gives 317 with a lower RWC than up here of all three. So this athlete may be closer to 317 currently, but when you include all three data points over the 6.5 week period, 311 is the estimate. Now, this athlete's WKO, which operates on a 90-day database as a default, WK estimate of FTP is 311, and FTP and CP are essentially conceptually the same. Stride CP, auto CP, is 309. So because those two, WKO and the Stride auto CP, which is a version of Golden Cheetah model, by the way, those two include the data, that 5K data, because they go back 90 days. Whereas this one is just using only the data that we submitted. And if we use it all the way back through the 5K, then this estimate and those multi-parameter power duration model estimates, 311 in WKO, 309 in Stride Auto CP, they tend to align fairly well. So very nice calculator, because you could enter multiple data points if you wish, or you could, if you do a CP test, you can do only the two, and it will give you various permutations and various models. I suggest you look at the 1/time model. That's been shown to be the most valid model with estimating running CP. Now, I just want to go over some of the other options that you have available that have been out longer. So one is a super power calculator. The super power calculator has a couple of different CP estimating functions, and I've used this one from different activities. And we go to enter, and I put the dates and the powers. I could enter either hour, minute, seconds, or seconds. You can toggle each one. I'm entering hour, minute, seconds. I like that. I wish ExPhysLab does that. I would have that toggle, but it's okay. We'll just do that calculation and get the seconds for ExPhysLab. And then we go back to main, and we get the calculated. So 306.65. Let's go back. 306.65 aligns well with when they're using, they're using the linear, when all three, because I entered the same three here, and it's the superpower calculator is coming up with this line here in terms of estimates. All right, 306.7 and 6.48, or 12.48, I should say. So the superpower calculator is using a linear model. Then that's the Sheets version. The superpower calculator web version, if I go and put in those three, the dates and those three data points, and using this particular calculator, I selected it from the various options, allows you to use from different activities, and I press calculate. This one actually comes up with a red flag and won't calculate it for you. It has a red flag say dates should be within 21 days of each other. Super Power Calculator does not have that red flag, but it does give you these particular instructions. And in those instructions, it says at least 2 activities, and it gives you the domains, and within a 2-week period, ideally. And that goes back to what I was saying at the outset. For validity reasons, you don't want to have widely spaced apart tests in terms of weeks or months. So this one doesn't have that red flag if you try to insert dates that are too far apart, and neither does ExPhysLab. It'll allow you to put, if this was a year-old data point, it'll still calculate. It doesn't give you the red flag. This one doesn't have the red flag, but gives you the advice here in the instructions. The superpower calculator for sheets, superpower calculator web does give you a red flag. But let's just get rid of that and calculate it. And I need to change the calculator from a CP test. And we're going to go this way, this way, this way. This was 363, 3 minutes and 8 seconds. And this one was 329 and 12 minutes and 6 seconds. And we calculate, and 317.12 with 8625. So as you see here, we know that the superpower calculators are using a linear model, not the linear 1/time model, but it doesn't matter when you have only 2 values. They're producing the same estimates, okay? If the final surge calculators for CP tests only allows 2 values, So it produces that same 2 value that you get here from value 1 and 2. Same values there as in there, and same values there as it is here, as it is in final surge, as it is here. Now I'm gonna go back. We've already made this point that it's a linear model, not a linear 1/time model. And what I'm going to do is I'm going to delete this September 5K, go back, and we can see that it comes up with the same value. So you could use any one of those 4 different calculators, and you're going to get the same estimate if you're entering the same CP test values. But when you start entering more than 2 and from multiple dates, the ExPhysLab is the one that I prefer using in that case, where again multiple tests from multiple dates. Hopefully the dates are not more than 4 weeks apart, and certainly ideally less than that, 2 to 3 weeks apart. Enter them into this, use the linear 1/time model, and you're going to get a pretty good estimate. And as I said, in this case, it aligns pretty well with what WKO and Stride were producing from the same background data within that 90-day database. So there you have it. I'm going to put the links for all of these calculators in the description. I'm also going to put a link to an article that I wrote that has links to all these calculators. I'm going to update that article to include this calculator, and they'll all be in the description of this video. So have a look at those links, play around with it yourself. And if you use this one, remember these are really talented people behind this, and consider supporting them via Patreon if you're using this calculator to a degree of regularity. So thank you for watching. We'll catch you next time. Bye-bye.